Good morning. In this lecture video, I'm going to explain timer operation. That means different modes of operation for the timer. So as we know, when a program is a timer increment by 1 for every machine cycle. That means each machine cycle has 12 pulses, clock pulses. So hence 8051 timer counts internal clock frequency which is divided by 12. So for example, if the crystal frequency is 11.0592 megahertz and that is divided by 12. So timer frequency is equal to 11.0592 megahertz divided by 12, that is equal to 921.6 kilohertz, and the timer period is equal to inverse of frequency. So 1 divided by 921.6 kilohertz, so that is 1.085 microsecond. That means a timer increments for every 1.085 microsecond. Timer increments for every 1.085 microseconds. Now we'll see different modes of operation. As you know, we have mode 0, mode 1, mode 2, mode 3. We'll discuss those. See, as you know, 4 modes depending on the values of bit M1 and M0 and T-mode register. They are mode 0, 30 bit by timer bar counter, mode 1, 16 bit, mode 2, 8 bit auto reload, and mode 3, split timer mode. Let's see timer mode 0 operation. So again here, source of clock is same, crystal frequency divided by 12, and it generates the pulses to be count, uh, and C bar T bar should be equal to 0, and the pulses are connected to one input of AND gate, and another input of the AND gate is timer run control bit, that is TX. It is 0 for timer 0 and 1 for timer 1, and output of this is connected to TLX. So it is a 5-bit counter. I mean, it counts the pulses which are received from the divided by 12 circuit, divided by 12 circuit whenever TRX is 1. So it is keep counting. It is keep counting. The maximum count is 5 ones. So 5 ones means it is 32. In decimal it is 32. Again, output of this TLX is connected to THX, that is used as a 8-bit counter. So the source for THX is the frequency. Here TLX divides the clock frequency, machine cycle frequency divided by 32. That is connected to THX. So THX is 8-bit here. So that means the maximum count is, since it is a 13-bit, no, maximum count is 1 triple F. When it becomes 0, the corresponding timer clock is set to 1. So this output of THX 8-bit counter is connected to TFX. So this is overflow flag, and then it is given to the timer. So this is timer 0, that is 13-bit timer. That means here the mode select bit is 0 0, and THX is an 8-bit counter and TLX is an 5-bit counter. So timer frequency, that is 1/12 of the crystal frequency or oscillator frequency, is applied to TLX as in the figure, and this frequency is divided by 32 in TLX, and then that is applied to THX. So THX count the original frequency, crystal frequency, divided by 384, that means 12 into 32, 384. So it is a 13-bit counter now, can hold a values between 40H to 1FFH in TH resistor. So whenever timer reaches its maximum count of, that is 1FFH, it rolls over to 0, and then the corresponding timer flag TFX is raised. So this is about mode 0 operation. And for mode 1, first we'll consider one example. For crystal or oscillator frequency 6 megahertz, that is divided by 12. So the frequency of TLX is 0.5 megahertz. Again, frequency for THX is 0.5 megahertz divided by 32. So again overflow occurs when the THX reaches the maximum count, that means 256. So again this frequency is divided by 256, that becomes 61.035 Hz. So its overflow time is 16.4 millisecond. So for every 16.4 millisecond it overflows. Suppose if the initial value is 00, if the initial value is 00, the timer overflows after 16.4 millisecond. Okay. Now see, this is the mode 1 operation. Mode 1. Only the changes is compared to the mode 0. So TLX is 8 bit. TLX is 8 bit. And the maximum count is, since it is a 16 bit, no, maximum count is 4FH. So when 4FH becomes 0, corresponding overflow occurs. Corresponding timer flag is set to 1. So here mode select bit is 0 1. These are the changes. Okay. And in TLX the frequency is divided by 256. So THX counts the original oscillator frequency divided by 3072 decimal. Okay. So since it is a 16-bit timer bar counter, okay, counter can hold the values between any values between 4FH, 40H to 4FH, and timer rolls over when it reaches the maximum value. Okay, this is the one. It is very similar to mode 0. Only the changes is TLX is 8 bit. For example, again, if you consider the same, if the oscillator frequency is 6 megahertz, so the frequency for TLX is, that is divided by 12, and frequency for THX is this 0.5 megahertz divided by 256. So it is 1953 hertz. Again, that is divided by 256, so 7.629. So overflow frequency, and overflow time is inverse of the overflow frequency, that is 0.131 second. So if the initial value is 0, timer overflows in mode 1 for a very 0.131 second. Now we'll see characteristic and operation of mode 1. So mode 1 is a 16-bit timer. That means it allows any values from 40H to 4FH to be loaded into TLX and THX register. After loaded with the initial value, timer must be started using an instruction set bit TRX. That means set bit TR0 for timer 0 and set bit TR1 for timer 1. And then timer starts count up until it reaches its maximum limit of 4FH. And then TFX, timer flag, is set to I when it rolls over from maximum to 0. After that, TFX can be monitored when this is raised. When the flag is raised, one option would stop the timer. You can stop the timer using an instruction clear CLR TRX bit. Otherwise, to repeat the process, the register THX and TLX must be reloaded with the original value, and TFX must be reset to 0. That means it should go back to the where we loaded the initial value. That means step 2. Okay. This is the characteristics and operation of mode 1. So for mode 0, again the same steps, only the changes is 13-bit timer and allows any value between 40H to 1FFH. Apart from this, it is same. So one point we should remember here: every time we should reload the initial values. Every time we should reload the initial values in timers mode 0 as well as mode 1. So to avoid this uh, reloading the initial value, we have one more time mode of operation, that is mode 2. That is mode 2, timer mode 2 operation. In this mode, so no need to load the initial value again and again. That means here also pulses are derived from divided by 12 circuit, okay, and that is connected to AND gate, and another input is the TRX, and this pulse is applied to TLX. That means TLX is used as a 8-bit timer bar counter, 8-bit counter, and THX is used to hold the initial value. So copy of the initial value is copied to TLX. Okay. So here since it is 8-bit, timer flag is set to I whenever it rolls over from FF to 0. Then corresponding timer flag is set, time overflow flag is set, and then it's going to interrupt. So whenever it overflows, it gives a signal to THX. It loads the copy of this into TLX. No need to reload again and again. We have a auto reload mode. Okay. So this is about timer mode 2, that is 8-bit auto reload. So mode select bit is 10. TLX is 8-bit counter. THS is used to hold the initial value to be loaded into TLX. When a timer overflows from FF to 00, timer flag is set to 1. Also initial value in THX is loaded into TLX. So in auto reload, THX is loaded with the initial count and copy of it is going to TL, leaves TH unchanged. So as many applications including setting baud rate in serial communication. I mean, to set the baud rate in serial communication, we use mode 2. And these are the characteristics. These are the characteristics. So same characteristics as we observed in mode 0 and mode 1. The changes is it is an 8-bit timer bar counter. So hence the values FF sorry 00 to FF to be loaded into any values to be loaded into THX. And apart from that, see, whenever TLX overflows from FF to 0, TL is reloaded automatically with original value kept in THX. No need to reload the value. So to repeat the process, simply clear the TFX. So this makes mode 2 auto reload. Okay. So in the next video, we'll discuss mode 3 operation. Thank you.